This video will cover the second section of Chapter 6, where we'll focus on the uniform distribution. We'll look at what that is and use that to calculate probabilities. The uniform probability distribution, or for short, the uniform distribution, is a probability distribution where each of the range of values that are of equal width have an equal probability of happening. So uniform equal probabilities. We often call this distribution the distribution of little information. And the reason we do that is because each range of values have the same probability. So it doesn't really tell us a lot about what's going on. And in fact, we often apply the uniform distribution to cases where we don't have a lot of information about how the random variable actually behaves. So we say, let's pretend each unit has an equal chance of happening. It's the best we can do. So how we define the function for the curve. This is the function, the density function, f of x, and this is what's called a piecewise function if you haven't seen this before. So for one piece of the domain, or the input values for x, we're going to have one functional value, and for the other pieces of the domain, we're going to have another functional value. So suppose that this distribution covers the range from a to b. The values on that function between a and b are 1 over b minus a. If we're not between a and b, there's no probability associated with being there, so our function is going to have a value of 0. So here are a couple of examples of uniform distributions. Suppose the range of interest is 2 to 5. So maybe we were talking about the probability of customers coming to our booth between 2 and 5 p.m. We've got 1 over 5 minus 2. Well, that's really 1/3. For each of the possible 1-unit values between 2 and 5, so for the range of 2 to 3, 3 to 4, 4 to 5, each of those has a 1/3 chance of happening. So the height of this density function is 1/3. Notice that we don't really have that other part in here, the 0, because for each of these values outside of the 2 and the 5, that function is really 0. So we sort of leave that out. Here's another example where the range is from 3 to 8. So 1 over 8 minus 3, I get 1/5. The height of this function is 1/5 or 0.2. As for any probability distribution, we need to be able to calculate the expected value or the mean. To do that for the uniform distribution, we take the simple average of the two endpoints. So a plus b divided by 2. To calculate the standard deviation, we take the deviation between b and a, so b minus a, square that, divide by 12, and then take the square root of all of that. That is our standard deviation. So here's an example on a range from 2 to 6. The expected value, or the average, is 2 plus 6 divided by 2. 2 plus 6 is 8. Divide that by 2 and we get 4. The standard deviation for this distribution is b minus a, or 6 minus 2 squared, divide by 12, and then take the square root. So if we do that calculation and simplify, we will get a standard deviation of 1.15. So let's work through an example. Pretend that we're selling yards of fabric, and we can sell any amount of fabric between 3 yards up to and including 6 yards. So our lower limit is 3, our upper limit is 6. We can define the density function. The density function is 1 over 6 minus 3, or 1/3. That tells us the height of the curve between 3 and 6. So our density function has a height of 0.3 between 3 and 6. So we can sell exactly 3 yards worth of fabric. We could sell exactly 6 yards worth of fabric, or any range of values in between. But because we can measure the fabric to many, many, many decimal points of precision, we're not going to talk about selling exactly 3 yards of fabric. So step 2 is to define the event of interest. Suppose we're interested in finding out the probability of selling more than 4 yards of fabric. So pretend that this mark here represents 4. We're interested in finding this probability. Calculate the required probability. So we want to know the probability of x being greater than 4. To find the probability of x being greater than 4 is really to find the probability of being between 4 and 6. So we're going to take that density function and multiply it by the range between 6 and 4. Well, this is the range of values that we're interested in knowing about. This is a deviation or a range. There are 2 units between 6 and 4. So I'm going to take my density function of 0.3, multiply it by this range between 4 and 6, or 2 units, and I find out I have a 2/3 probability of selling more than 4 yards of fabric. So for another example, pretend we have between 2 and 6 as our possible values in this uniform continuous probability distribution. We know that means we have a density function of 1/4. Suppose we're interested in finding out the probability between 3 and 4.5. Find the probability between 3 and 4.5. We need the density function, 1 over 6 minus 2, times the range of values that we're interested in looking at. So 4.5 minus 3. The density function is 0.25. The range of values that we're looking at here is 1.5. The probability of being between 3 and 4.5 in this uniform probability distribution is 0.375.